Today's video is about cryptography and the blockchain. So cryptography is a digital collection of zeros and one, and its core language is known as a binary code. When it comes to cryptography and blockchain, there are four main forms. The first one is the hash function. So as we can see, we have a data and we can put an input. And due to a cryptographic hash function or an algorithm, we get an output in a form of the hash. This is a very important because without this, we would not be able to have a blockchain or a Bitcoin. The second one, which we show, is a proof of work. So we use hash to verify data, and now we have the possibility to use and to put a big amount of data in a certain block. So thanks to this, thanks to the proof of work, we can find out a nonce and the hash that we need to use. The thing which we need to keep in mind is that the same input leads to the same output. As soon as we change the input, the output is also changing. The third one is the public and the private key pair. So for this one, we need to say that the public key is available for the public, and the private key is only my key, which I shouldn't show to anybody. So here we have some random private key that we can use. So we use this random number. And with this, we can create a signature. In order for her to have an access for the public key, we need the private key. So, for example, we put a message here, yes, hello, and with my private key, I am able to create a message signature. Thanks to that, we know that who signed this one had an access to the private key. So now we are able to verify it. And we know that the public key is known to everybody. And for this to happen, we need an elliptic curve digital signature algorithm. So now we can see how it works when we want to make a transaction. So for example, we are trying to send $20 from my public key to another public key, and we use my private key, which I don't show to anybody, to sign and to create a message signature. We send signature by this private key. Now we can verify it and we can see how it works in the blockchain. So as we can see, we know the Coinbase, so we are sending $100 or $10, and here we can see the public keys from which we are sending, and here we can see the signature. If we, for example, change somewhere a price, we can see that not only the block became invalid, but also the signature changed, because only with the private key we are able to derive this signature, and as soon as we change what happened in the block, it changes too. So thank you for your attention, and I hope now it's clear why cryptography is very interested, it is very important in the blockchain.